All right, well, let's get started. My name is Mark Hatfield. I'm the president of HECO. This presentation is intended to help you kind of have a path towards how do you make the right decision between repair or replace that motor. And this kind of ties to any commodity. It's not really, even though it's motor specific, you can kind of use the same philosophy for any type of repairable commodity. Motors are reliable when they're managed properly, but they still fail. We all know that. It doesn't matter what we do. You can put a new one in and there's going to be some failure along the way. Organizations must make decisions right to get the production back running again. However, organizations need to realize that decisions made during this time can significantly look at the future reliability and the efficiency of the equipment, the decisions you make at this point, because everybody's under the gun at that moment. It's important to establish a repair replacement break point. So this is where we got the inventory figured out. We're kind of looking at everything. We got to figure out, where do you replace it? You know, what's that break point that you clearly define, so that everybody, your decision makers in your company, can make an educated decision. The decision to repair or replace should be predominantly a financial one, which we know it is. While repairing the motor may require fewer initial costs, the purchasing of it, compared to purchasing a new motor, the total operating cost of the repaired motor may be significantly higher, depending on the cause of failure, the age of the motor, the ability of the repairer to be able to do the work, the annual operating hours of the motor, the overall efficiency of the motor after repair. So once that motor falls below a certain criteria, then you got to look at it from an economic standpoint. So if you look at a standard T-frame motor or 50 horsepower at 75, that's kind of the typical break point in a lot of companies. They look at a 50 to a 75 horsepower T-frame standard motor. I can throw it away. I've got spares. You can't really rebuild that completely. You can throw bearings in it and do some things, but you can buy a motor for less money. And so that's where you start looking at 60, 70% of cost of new. Where's that repair threshold? It's a starting point, and it's just the beginning of a program. By starting your repair replacement analysis, when you go through this process, we talked about the inventory. If you look at it from the large motors down, it's easier to make this decision. To look at, you know, it's obvious that, okay, you get larger down to the smaller, all of a sudden you got this range of smaller ones that you go, they're standard motors, they're T-frames. Okay, I'm going to replace it. But you know, this isn't perfect in all worlds, because you'll end up with that special small motor that you can't even buy because it's special. Or if you can buy it, it's 8 weeks out or it's 10 weeks out because it's special. So you run into that same situation. Yeah, you see heads shaking. So yeah, we've seen them all. But your standard T-frame is stuff that you got a lot of generally in most plants you can replace. Having the right partner that understands your financial needs will make your life a lot easier. So having a partner that understands what it costs to renew compared to the repair makes your life a lot easier, because they're going to be working for the right solution for you. They also understand the plant applications, so you make the right decision first on that. So they're going to understand that you've got, you know, these motors and these applications. They maybe have to be totally enclosed, fan cooled compared to an open drip. They're going to last longer, so they understand those things. And having a vendor partner that can help bring the right solution by comparing the repair compared to the replacement makes your job a lot easier, and we're looking at it from an increased reliability standpoint. How do you make that decision on repair versus replacement? In some cases, the repair is the right decision. Sometimes it's, you know, the repair is the right decision based on the application design of the motor. New designs may be more efficient, but the original motor is better suited for than the current replacement. We found that on some applications where you stay with the one you got. It's worked, it's been the right motor, it fits, You know, current replacement motors are generally smaller in size, making them sometimes harder to install in the original applications. You got to build up the base, you got to do things. And think about this, you've got a mass that's twice as big. I mean, we had an application, a power utility that was a boiler feed pump that was, I think, 3,000 horsepower, and the motor was probably this whole area, and the replacement motor is probably as big as that table. Now, that doesn't mean it won't do it. It works the load, but what we find is that, you know, when you start looking at those things, and I'll talk about this in a minute, you know, what's the reliability over the long haul? How the new motor is constructed can affect the reliability over time. Again, we talked a little bit about this, copper versus aluminum rotors, the overall physical size, the winding design, all these things factor into reliability. Is the new motor able to be rebuilt? There are some people out there, some manufacturers trying to make a special motor that you got to go back to them. It's kind of like the car dealer. You know, how many, probably 90% of the people probably take them back to the dealer, unless it's an older car. You know, you just feel like you have to go back to them because they want you to go back to them. They want you to have that service. They are building some motors where they have special installation systems that they say, oh, you got to come back to me to buy. So be careful of that. Be conscious to that. Is the lead time for the new replacement too long for the current needs, and is the repair the only feasible option? Sometimes that's it. Now you can plan ahead for the future, but right now you don't have a choice. You got to get it repaired, you got to move forward. In the past, motors were built to last 25, 35 years, and most were over-engineered. We all know that. I mean, just like everything we buy, you go to the past with tools or anything, they were always over-engineered. They were heavier, bigger. Not saying they were the best solution, but they were over-engineered. Today's motors are designed to last between 15 and 20 years and are engineered with little to no leeway. And that's not anything against the manufacturers. What's happened is it's driven costs down. Everybody wants to buy stuff for less money. They want it smaller package. So what have they done? They've increased the insulation system so that they run hotter. The insulation will accept it, and they pump more horsepower into a smaller frame. So it's just reality over time. They're not going to last as long as the motor that we've seen, some that have been in for, you know, 60 years and been running, you know, and the whole guts can be rebuilt. Sometimes the replacement is the best option. So you just gotta take these factors into consideration.